independent variable, mean of a data set, standard deviation, reliability, dependent variable, error bars, t-test, correlation, some of many terms that we need to learn within statistical analysis to ensure we calculate the statistics correctly. Today we're going to explore statistical analysis in much more detail. Hi, welcome back to the Physical Educator. Today we're going to talk about statistical analysis. This is great for Unit 6, but it's also important to learn for your preparation for your internal assessment. We're going to start, as we usually do, with the assessment objectives to see what it is you're being asked to do within this unit. So it's a double-edged sword, this one. Not only is the 7 specification points that will prepare you for Paper 1 and Paper 2, but also your internal assessment. Many of these terms will be needed. The knowledge that you will acquire here will also be needed in your IA. So let's get stuck straight into it. Before we start, I just want to talk about the 3 main terms today and their importance. So if we have an understanding of them before we start, that's great. First one is standard deviation. What we're talking about with this term is the reliability of data. So the mean within the mean, sometimes it's referred to. The spread of data around the mean. We also have a t-test, and this is looking for a statistical significance between 2 data sets and the amount of error within that data set. And lastly, we have a correlation, and a correlation is looking mainly on a graph with an X and a Y axis, looking at a relationship and how strong that relationship is. So first we need to look at error bars and how they are a graphical representation of variability of data. So error bars are as they sound, they are bars on the graph showing error. It is as simple as that. But where this can become slightly complicated is the different types of error bars that we can have. Now we can have standard error bars, and in your IA it's important to consider standard error, and it's usually a very small percentage of what it is that you're looking at. But this is standard error no matter what, it doesn't really change. Whereas standard deviation is always changing and it's dependent on the number that you have. So for example, we have 2 golf putts here. So an example I'm going to use a few times in the example I'm going to use a few times in this section is golf putts. Let's imagine we have 2 golf players and they're on the green, they've got 10 balls each and they're putting from 10 yards. What we can look at is how close to the pin they are with each 10 shots. And we can give them a mean, an average number out of their 10 shots on how close they are. And if we look here, number 1 has a smaller mean. The numbers are relevant. Player 1 has a smaller mean. Player 2 has a larger mean. So by looking at this, you could argue quite quickly that player 1 is more consistent because more of them putts have ended up closer to the pin. So what's the point in a standard deviation error bar? Well, if you look at the error bar here, although player 2's putts on these 10 putts in particular weren't as close on average than player 1, there's a smaller standard deviation error bar, meaning that the spread around the mean is smaller. This would infer that player 2 is actually more consistent. And it could just be that player 1 happened to put 1 in the hole, maybe 2 in the hole out of 10, and the others were quite far away. So if these 2 players were to do this again, would the results be the same? You'd expect player 2 to be the same or similar. Player 1, we don't know. Could be much worse, could be much better, could be the same. Nobody knows, and that's the problem with it, because there's such a big standard deviation. There's no guarantee in the reliability of this data. There's no guarantee that it can be repeated. The reason we use standard deviation is to try and allow for reliability, to try and prove that things can be repeated. And that's what you'll be using standard deviation for in your IA, to prove that your test can be repeated. And next we need to calculate the mean and standard deviation of a set of values. This is great within Unit 6, it could be multiple choice, or it could be an extended answer question. And also it's very important for internal assessment, as you'll be required to do this. Now, there is nothing to say that we have to calculate standard deviation by hand. Statistics can be very, very, very difficult, but we don't have to make it difficult in this section. We're allowed to use computer programs such as Excel or Google Sheets. So to figure out the mean, equals average, open brackets, highlight them all, close brackets. You might have to do this in an exam, so you might have to add up a few things with your calculator, but it will never be that challenging. Slide that across player 2's mean as well. Standard deviation equals STDEV, highlight the same data set, close the brackets, and this will give you your standard deviation. This is useful for your IA. In your exam, you're more than likely going to be given the standard deviation. You may have to calculate the mean. And with this, you can then answer the question in your exam. Just before we move on, note that the player 2 now has a smaller mean and a smaller standard deviation. As we suggested that might happen, what we've done here is given the players 20 putts instead of 10 over the same distance, and more than likely that's what would happen. Because that standard deviation is lower, there is more consistency, so you would probably find that the performer with the lower standard deviation will produce the most consistency. You can also use standard deviation in a different manner. It's not about the performer's reliability, it might be about your reliability in your data set, and you want to try and prove normal distribution, which we'll come to in a second, small standard deviation, and this is the reliability of your data in your IA, meaning that if it was repeated, similar outcome would be achieved. Next, we need to state that standard deviation represents variability of data, and it's the spread around the mean that we're looking at here. So what we need to do here is bring the data from that table to life, and we're going to do that first and foremost by putting it into a bar chart. So we've got two means. We also have two standard deviation error bars, and these very easily now visually can show us who had the better mean, who had the better standard deviation, and player 2 has got both. So you can argue that the player 2 would more than likely reproduce this outcome more consistently. But let's go one step further and look at this bell curve. And what this bell curve is looking at is the amount of standard deviation. When you calculate standard deviation and you have that number, one standard deviation is to take away that number from the mean, from both sides, add it and subtract it. And within that range is one standard deviation. You can do this for two standard deviation. So you get that standard deviation number, times it by 2, add it to the mean, take it away from the mean, and that range is 2 standard deviation. And you can do it for 3 as well. Within one standard deviation, to produce normally distributed data, you need 68% of your data to fit within that bracket. Within 2 standard deviation, 95%, within 3 standard deviation, 100% of your data. For your IA, what I suggest is that you look at 1 standard deviation, and if you can get 68% or above, brilliant. If you're just under 68% standard deviation, still include it in your data, but look at 2 standard deviation and see if you can get your data set within 95% within 2 standard deviations. This is what it looks like, and this is how you can do it. Player 1 and player 2 and their 20 putt scores here, how many yards away from the pin there are. If there is 0, it means it's gone in. Like this big number of 9, that doesn't mean from 10 yards they've only gone a yard, or it might do. More than likely they've gone past the pin, hit it too hard, it's gone 9 yards past the pin, which you've got to remember with golf. So anyway, these are the scores, 20 shots. Let's talk about the statistics. The mean for player 1 is 5. The mean for player 2 is 3.9. The 1 standard deviation for player 1 is 3.03. Now we're dealing in full numbers, so I'm going to keep this simple. 3. Let's just say that 1 standard deviation is 3. What we do is we add 3 and take away 3 from 5. So that range is from 2 to 8. So every shot here that's in between 2 and 8 yards has a tick. It's the 0s, the 9s that don't have a tick. Add that number up and there's 70% of player 1 puts that are within 1 standard deviation. 2 standard deviation for player 1 is 6. So that's 0, or minus 1, so it's 0 to 11 for this player, because he's taken the 6 off down to 0, or minus 1, but you can't have minus 1, it goes in the hole. And then 6 up is 11. Every shot is within that range. We're only going from 10 yards, so every shot is within that range, 100% 2 SD. Going to player 2, there's the shots. The mean is 3.9 and it's 1.29. So again, let's just do 1. So it's 3.9. So it's roughly 3 to 5 is our range here. So anything in between 3 and 5 has a tick. Anything 2, 6 and 7 has a cross. 80% of player 2 is within 1 SD, but because of the 2 7s for player 2, only 90% within 2 SD. So it gives us discussion points here with regards to the standard deviation, but ultimately if you're looking at 1 standard deviation, brilliant, we have normal distribution.
So we've just looked at standard deviation, we know what it is. Now we need to explain how standard deviation can be used to compare data sets from different samples.
So what does this all mean? Standard deviation measures how much a set of data varies from the mean. That's where we need to start with this. It's your first bit of understanding. It informs about the spread of data and is an estimate of the average variability, so how much it varies around that mean. This spread of data is measured in the same unit of measurement as the original data. For our example, 5 was the mean, 5 yards for player 1, 3.03 yards was the standard deviation. It can also be calculated by figuring out the square root of the variance. But we're fortunate we can use Excel, Google Sheets with our formulas, but it is worth noting that knowing that sentence, the square root of variance, could get you a mark on your exam without knowing how to do it. To summarise, a smaller standard deviation clustered around the mean demonstrates a reliable data set, whereas a large standard deviation infers unreliable data. If the data set has the same mean, that does not mean they have similar standard deviations, because it depends how that mean has been realised.
Next, we need to outline the meaning of coefficient of variation.
The coefficient of variation is basically standard deviation as a percentage. So it puts it in relative terms when comparing data sets with different means. To provide a practical example of this, if we're sticking with the golfer, let's say we've got them over 10 yards, which is the distance we've covered so far in our examples. But then let's say the golfer practices over 20 yards. Let's say the golfer practices over 5 yards. There's going to be different means considerably. Over 5 yards, the mean might be 1 yard or half a yard. Over 10 yards, as it was for our example, it could be anything 2, 3, 4 yards. Over 20 yards, the mean could be 7, 8, 9 yards. So it's very, very different for the golfers over different distances. But by figuring out as a percentage, it puts it into relative terms so each of them can be compared, so they can see which one they're stronger at, the smaller distance or the bigger or the middle distance. This can also be used by coaches in many sports and relevant for coaches in many sports. Let's jump onto the track in athletics and let's consider a sprinter for a second. A sprinter, as you've seen many times, and you've probably done this with acceleration in biomechanics, where you look at the splits of a sprinter every 10 meters and how the different speeds over them 10 meters, you can infer an acceleration change, but also what's going on for the sprinter. The first 10 meters, 0 to 10, will be gaining a lot of acceleration because they're bursting out of the blocks. But they're not as fast as they are at 60 to 70 meters, which is their fastest split within their sprint. And what a coach could do is get the sprinter over a period of the season or over a short period of time, can collect maybe 7, 8, 9, 10 full 100-meter scores, but instead of just going on that full 10 seconds or whatever it may be, you can look at the means of each of the splits with a standard deviation, figure out a coefficient of variation for each of them splits, and it gives you a percentage that's comparable. So it might be 5%, 6%, 7%, and each of them are comparable with each other. So you can see where the strengths and the weaknesses lie because the percentage puts the number into real terms. It's a very simple equation. To calculate this, it's simply standard deviation divided by mean times by 100.
So we've looked at everything to do with standard deviation. Now we're going to look at t-tests, statistical significance. That's what a t-test is, and we're looking at unpaired and paired t-tests.
So there's potential here to really get yourself confused. T-tests are a very technical statistical test that can be very diverse and very difficult to get your head round. Now, for this course, we only need to look at 2 types of t-test, and there's many types that you can look at. So all I'm going to do here is keep this unbelievably simple and pick out what you need. So to start off with, a t-test is when you want to look at statistical difference between 2 data sets. So you're not looking at a relationship. So for example, you're not looking at how many ice creams an ice cream man sells on a hot day. There'd be a relationship on 2 axes, X and Y. You'd look for a correlation, there'd be a relationship. You're not looking at the reliability of the data and the repeatability of the data, that's the standard deviation. Here you're looking at a difference. So you might be comparing things, but to look at a difference, that's the comparison. You're trying to prove significance. What we're looking for with a t-test is error and the significance of that error. So what that looks like, we have a value, and it's a p-value, and this value is 0.05. And what you want to prove with your t-test is that your statistics are 0.05 or lower, so 0.04 or 0.03. What this number equates to, if you put it into a percentage, 0.05 is 5%. So what you're stating is that your data is 95% without error. And that's the significance that you're trying to prove. If you can get 0.05 or less, then your statistics are significant. If you get more, a higher number, then it's insignificant. And that's what you want to try and prove with your t-test. And thankfully for us, when we punch the numbers into Excel, it does it for us, which is great. The 2 types of t-tests that we look at. First, we have an unpaired t-test. So again, to keep this simple, that means you have different groups tested once. So it's independent of the variable. So the variable stays the same, but you're applying 2 different groups to that variable to see the difference between them. An example here might be males versus females doing anything as long as it's the same, and what you're drawing upon is the difference between the male and the female response. So it could be a cardiovascular response, it could be a respiratory response, it could be a speed response or a muscular response, but you're looking for the physiological difference between them, and the variables stay the same. What changes is the male and the female. Again, you could do this with age. You could have somebody who's an adolescent against somebody who's a young adult against a mid-age adult against an old adult, and you would expect different responses to that same variable, that same test that you're doing. And this would be an unpaired t-test. Different groups tested once. Or you might choose to do a paired t-test. And a paired t-test is the same group tested twice. And what we're depending on here is the changing variable. So examples here, and examples that I've done with students in the IA, particularly living in hot countries, is a change in temperature. So your group of students could perform something inside in the air conditioning or on a cold morning in the winter, and then you do the same exercise with the same group of people in a hot climate, 35 degrees Celsius plus. And what you're looking at is the changes that take place. So it might be heart rate changes, it might be blood pressure changes, it might be core temperature changes, it might be that you weigh the clothes on the athletes to see the amount of sweat that's produced. Many different things, but you're looking at the same variable, but you've changed the environment. That's what has changed. Or it could be a mode of exercise. So you could have the same groups of people, you might do the bleep test. The same group of people might do a VO2 max test. The same group of people might do Harvard step test or the 12-minute Cooper's run. And you're looking at these stats, the same group of people have been tested again. So it's the same people producing the scores, but what changes is how they respond. And that's the variable that changes. If this is what you wish to do within your IA, that's a paired t-test. And that's the difference between an unpaired and a paired t-test.
And lastly, we need to explain that a correlation does not mean there is a causal relationship between two variables.
So here, it's really important that we remember that a correlation, yes, it is used to describe a relationship between variables. But even though it appears so, it does not imply there's a causal relationship. Correlation indicates the magnitude of relationship, not that simply one exists. So what we can use to describe this magnitude of relationship is something called the correlation coefficient, and it's a positive or a negative value expressed in between -1 and 1. So for example, if it is -1, it's a negative relationship. If it goes closer to 0, it means there's no relationship and it's more random. And if it goes to +1, it's a positive relationship. So some examples here at the bottom. So if you look at powdered donuts up one axis and chocolate donuts across the other axis, the more powder that is on the donut, so it goes up towards the top of where it says powdered donuts, the less chocolate is on it. And the more chocolate that's on a donut, the less powder that's on it. So it's a negative relationship. Or, keeping with donuts, cost of donuts and the number of donuts that you get for the cost. It's a strong positive correlation. Similar example I gave before, ice cream sales for an ice cream man on a hot day. The hotter the day, the more the sales. Going into the world of sport, the taller a basketball player, the more rebounds they will collect. That would be another positive relationship. But that simply doesn't mean that because there's a correlation, that means there's a relationship. Because if you're 7'5", yes, you're more likely to take more rebounds than someone who's 6'3". But just because you're 7'5" doesn't mean you're going to take more rebounds than someone who's 7 foot. You might not be as an effective centre as somebody else. So it doesn't simply mean there's a correlation. We're explaining the magnitude of that relationship. If it's more scattered, like the bottom left, that's 0, and that means that your data has no relationship whatsoever. So if that was in your IA, that would end up proving your null hypothesis. And that's everything really that you need to know with the correlation. It is quite simple. It's a great and effective one to use within your IA. It's easier to find a relationship than it is to try and prove statistical significance. But with that said, the statistical significance IAs, I believe, are more interesting and demonstrate your statistical understanding.
PowerPoint on Unit 6, including statistical analysis with standard deviation, t-tests and correlation, including QR codes and suggested reading, as well as study design, different types of tests, components of fitness, and principles of training. Visit the TES website and check out the Physical Educator channel there. Thanks for watching. See you again soon.